Okay, part one of STAAR review. We met and we discussed certain things. I'm going to divide it into two parts. I feel like the two parts will go together. So, part one, transversals, talking about all the vocab of when you have parallel lines, what's going to be considered the outside or exterior and the inside, interior, and how all the stuff is going to be based on 180 degrees. Then for the second part, all the variations of Pythagorean theorem, which is going to involve the distance formula, which is when you're given a line on the coordinate plane, how far is it from one point to another? And then the question of verifying if it's a right triangle. Then solving for a leg, which would be A or B. I feel like you're pretty good at solving for C. And then using squares to determine a missing side length or verify the existence of a right triangle. All right, so first, the vocabulary intensive should be a refresher. But we do know that whenever we're given information like angle 1 is 65 degrees, we're going to put that in. Just as a reminder, we had all straight lines are equal to 180 degrees, because if we were to do all the way around, we'd have a circle, and that's equal to 360 degrees. So if we know that angle 1 plus angle 2 is going to be 180, all we have to do is figure out what's left. So that's when we'd have the 180 minus 65. We should have 115 degrees. Now we can use all the vocabulary we know to go ahead and figure everything out. So vertical angles would be 2 and 4, 1 and 3. So just from the rule of vertical angles, we know that 1 and 3 are 65 degrees. Vertical angles are great. 2 and 4 are vertical angles. 115. You could also go with angle 1 and 4 and say that that was 180, and then you have your 65 plus 115 and get 180 again. Whenever you add all four, you should get 360. Now, if we want to go for exterior versus interior, we can look at angle 1, and what would be exterior to that? Angle 7 and 8. What makes it alternate is whenever it's crossing the line that goes through the parallel lines. So the ones that are going side to side, the line that crosses through is what makes it a transversal. On alternate exterior, so other side exterior, angle 8, give you your 65 yet again. Go vertical from there. 65. We could also switch it up and start from angle 4 and say alternate interior, because they're inside of the parallel lines and they're on the other side of the line that intersects them. So 115 will be also at angle 6. Go vertical from there, 115. Pretty straightforward. Basically all you're doing is, do you know the vocabulary? Whenever we have something like this, it's going to be testing, do you understand what happens when you put 7W and 2W together? What should you get? Well, you should get 180 degrees, because whenever you're adding those two angles, you get half of a circle. So it's saying, okay, when I add those two up, 7W plus 2W, I should get 180 degrees. Okay, well, how many W's do you have over there now? Looks like you have 9 W's. 180 degrees. That looks like a one-step equation. So you're sitting there going 9 times something equals 180. What you could do is divide both sides by 9. And, you know, if you wanted to solve any of these, stop the video before I go over it and, you know, see where you're at. Like when we go over the 5x and x plus 32, go ahead and just hit the space bar, stop the video, and try and fumble around yourself and see what you get. So 180 divided by 9 should give you 20. So that's going to be W equals 20. Let's see if that makes sense. So we've got 7 times 20 is 140. And we've got 2 times 20, which is 40. So does 140 plus 40 equal 180 like we said it should? Yup, certainly does. So that makes sense. W is 20. And whenever you have your multiple choice test, you can substitute numbers in for W. So if like there was one that said 10, you could say W is 10. Okay, 7 times 10 is 70. 2 times 10 is 20. Okay, so does that equal 180? No, it equals 90. What you should know about the 5x and the x plus 32 is what type of angles those are. They are vertical. And we know that from what we just did previously that vertical angles are equal. So you have 5x is equal to x plus 32. All right, so now all you have to do is get all the x's over to one side. You're balancing a one-step equation. Minus x, minus x. You have an x, you took away an x. There are no more x's over on that side. You're left with only a 32. You had 5 x's and you took away an x. 4x. Now we're back over to where we were with the 9w equals 180. We're solving a one-step equation. Divide both sides by 4. X is equal to 8. Okay. You can also use your multiple choice and substitute that in to say, all right, well, 5 times 8 is 40. And then 8 plus 32 is 40. Does 40 equal 40? Yes. What this is testing is can you substitute variables and also at the same time analyze a transversal to know the rules of angles and the vocabulary. Okay. It would be probably a wise idea to pause the video, go through W and Y, X and B, etc., and see what you can remember. There's going to be some stuff that you don't remember, and that's quite all right. So that's why we're reviewing. I'm going to go ahead and go. So W and Y make vertical. We know that vertical angles are equal. X and Y. X and Y are supplementary. Because they are two angles that add up to be 180 degrees. I'm reviewing this too, if you can't tell. X and B would be corresponding angles. They're on the same side, but one's on the exterior and one's on the interior. That's what makes them correspond. You can see that they also look the same. Not that that's ever a measure of what you should do. Y and B are same side interior. W and C are alternate exterior. So I'm going to put alt exterior. Z and B, alternate interior. D and C would be supplementary as well. All right, so how long is the line? It's like, oh, I have no idea. I can't count the squares. I have no idea. I made this line up. I have not solved this problem. I have no clue. But what we can do is make a right triangle and then count the side lengths. 1, 2, 3, 4, 5, 6, 7. So we know this one's 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that one's 9. We have no idea what that is. And if you want to use X, cool. Just I'm using a letter because I don't know what it is. The most appropriate letter to use would be C. So you know what? I'm just going to go ahead and go back. I'm just going to use C. Insert the right angle. We know that's the hypotenuse. All right, now we know that we're using Pythagorean's theorem, which is a squared plus b squared equals c squared. And you're filling in the information that you know. This is something you need to be meticulous about. Whenever you're filling in a formula, use the formula to fill it in. Don't start writing random stuff over here and going 7 squared is 49, 9 squared is 81, and then you're having to try and put all the stuff together. A is 7, B is 9. Now you're substituting it in. 7 squared plus 9 squared equals c squared. It'll also help you to it'll pay off in the long run whenever you read the question and then you look at the answer choices. This might be an answer choice. You don't have to go through the whole thing solving the problem. It's just which one is the proper way to set it up. So 49 plus 81 should give you 130. Pretty sure. 49 plus 81, 130. All right, just wanted to check. C squared. All right, so that's 130 equals c squared. This is where you would say, so I'd square root it, right? I'm like, yeah. C equals, all right, the square root of 130. About 11.4. It'll always probably round to the nearest tenth or hundredth, so this will be the most accurate answer you could find. And you know that it at least has to be larger than A and B. So if you came out with an answer like 8, you'd know that you're wrong because C is the hypotenuse, which is the longest side. Use the rules to verify your answers. All right. Is it a right triangle? You know that all the largest numbers are going to be C, and these are your A or B, okay? All you have to do is plug them into the formula. Does 7 squared plus 8 squared equal 11 squared? There's going to be the one that is going to have A plus B is going to be equal to C. Like 3, 4, 7. 3 plus 4 is 7. But you have to remember to square them. It's, do you understand using the formula? So you'd square 7 and get 49. Square 8, 64. 49 plus 64, does it equal 129 or 121? No. So then 9 squared, 81. 10 squared, 100. Does it equal 144? No, it equals 181. So 181 is not equal to 144. Get rid of them. 36 plus 36, because 6 squared plus 6 squared should equal 64. 36 plus 36 is 72. So 72 does not equal 64. All right, and then 3 squared is 9. 4 squared is 16. 5 squared is 25. 9 plus 16 is 25. So 25 equals 25. Yay! There's your right triangle. So solving for a missing side using Pythagorean's theorem. A squared plus b squared equals c squared. Okay, so basically whenever you have a and b, you add. Whenever you don't have a and b, you subtract. Then you find the square root. So that's the only major difference. Right now you can see that you have a, you can call that b also, whichever, is 3. You don't know b, and you know that c is 5. And it's going to have the right angle because they want you to know that right angles point at the hypotenuse. So you're going to substitute all your stuff in. 3 squared plus b squared equals 5 squared. Simplify one step at a time. You got 3 squared is 9 plus b squared equals 25. So you're like sitting there going, okay, I got to get b squared by itself. How do I get rid of 9? You subtract 9. Okay, that goes to nothing. You're left with b squared equals 16. So take the square root. And again, the square root right here, we haven't solved the problem yet. That might be your answer choice. B equals 4. That might be your answer choice. The actual problem setting it up might be your answer choice. And you also have to be able to recognize that 3 squared could be B, and then you could be looking for A. Doesn't matter because you're just looking for a leg. Now, using the weird square thingies. The reason that this matters is because the idea behind Pythagorean theorem is that it uses squares to make right triangles. So if you have a square that has a side length of 3, that means the other side length is 3. Same thing with 4. The other side length is 4 because it's a square. Other side length is 5. That means the other side length is 5. So really what you're doing is you're finding the area of 3 squares and putting them corner to corner to where they make a triangle. They're going to make a right triangle. If they don't, then the squares won't work, and you'll see them not line up. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. What it's saying is 9 plus 16 should be equal to 25. Does that check out? Yes, it does. 9 plus 16 is 25. This is a right triangle. Check. So just because it's using squares is just a visual way of representing what the theorem actually is. This is how it was created, by using squares.